Hello all, welcome to our next session in transportation engineering. I hope you have seen the previous sessions. We are in the last part of the geometry design topic under highway engineering. In this topic we are going to see vertical alignment. As the name says, so far we have studied about straight roads, how the geometry will look in the straight roads, how the geometry will look in the horizontal curves. I hope in horizontal curves, if you remember, we have seen super elevation, transition curves, extra widening, all those topics. In this session we are going to see vertical curves. Okay, the curve will be something like this. So if you try to understand, so we are going to see some vertical curves. Before that, the vertical curves are formed by gradients. So we will see something about the gradients initially, then we will go for summit curves and valley curves. Okay, so welcome to the again last session in our geometry design topic under highway engineering. So gradient, as the name says, it is nothing but a slope. Okay, so you can see the first, if you try to visualize, this is what I am discussing. You can see the right side bottom figure. So this is what I am discussing as a gradient. Actually this is a rising gradient, and if you go that side of the road, we will see a falling gradient. Okay, so this is nothing but a rate of rise or fall along the length of the road, as the name says. Okay, with respect to horizontal. So if this is a horizontal line, we are going to rise the road surface. Okay, so this rise in the road surface can be mentioned in the terms of slope 1 in n. 1 in n means, already we have seen this 1 in n in camber and also in super elevation. So for n meter or n centimeter or n millimeter, 1 meter rise. Okay, so if you project with the theta, so the tan theta will give you nothing but opposite by adjacent, right? 1 by n. So which is nothing but the gradient is mentioned in the form of n or n percentage. Okay, if there is a rise, this will be going upward. If there is a fall, it will be going downward in this direction. So this is what the gradient is. So when you are having a two gradients, so now as I mentioned, positive gradient will go upward, rate of rise, and negative gradient it will come down. Okay, so the deviation angle is nothing but how much one gradient is deviating from the other one. We will discuss about this deviation angle little detail in the summit curve topic. Okay, so you try to visualize this curve which is given at the bottom here. So for n percentage, n by 100, this is nothing but the slope of your curve. This is the alpha. So as I mentioned, try to remember only this one. The gradient is nothing but a rate of rise or rate of fall, which is mentioned in terms of 1 in n. Okay, let it be small n for now, don't get confused. We will see in coming topic how this deviation angle will influence us. Okay, so there are 4 types of gradient usually will provide in the highway engineering. Ruling gradient, which is nothing but a design gradient. Okay, so the design gradient, whatever required for our particular topography, we will design that. You can see the table right side also for a plain and rolling terrain. Ruling gradient, limiting gradient. Limiting gradient is nothing but minimum, at least we should provide this much. That is the limiting gradient. In some exceptional cases where the providing such highway roads will end in increased amount of cost, some exceptional cases we can even go for some exceptional gradients, which is given in the third column in the table. Okay, this is IRC recommended gradients table. So mostly ruling is nothing but the design gradient, which is what you want. Okay, which is what you have to provide at least. So we cannot provide 10% and 20%, ask people to drive in that. Okay, or you cannot provide 1%, 2% also. So there is some design gradient for different topographies, and in some limiting cases and in some exceptional cases in the different topographies. So there is also something called minimum gradient. Minimum gradient is for drainage purpose. I hope if you remember, in camber we have provided for a transverse gradient, right? So we provided a camber in the transverse direction, but in longitudinal direction the minimum gradient is provided. If the road is straight, I hope you can remember, so the water will stay, right? So if I have to provide a minimum gradient, so that in the longitudinal, in length direction, I will have some sort of drainage, so the water will go towards the drain hole, or it will reach the particular location where it can reach the camber and it will go out. Okay, so that is a minimum gradient. It is also provided for drainage in longitudinal direction. These are the 4 types of gradient terms we should know. And there is something called creeper lane. So when you are providing a gradient of something extremely unclaimable for heavy vehicles, there will be a straight road going around the gradient. Okay, this is only for a slow moving vehicle. So that is nothing, that is called as a creeper lane. So for the heavy slow moving vehicle which cannot take that much of gradient, consider they will go very slow, like 10, 15, 20 kilometer only they can go. For that type of transports, where they have provided a creeper lane. So in that creeper lane the vehicle can negotiate the gradient and go around, and they can reach the particular road. Okay, so the next topic in the gradient is grade compensation. I hope if you remember, I told you when a vehicle is negotiating a horizontal curve, so when it is a straight road everything is fine. When it is negotiating a horizontal curve, the front wheel will negotiate in this direction and the back wheel will negotiate straight. In that way there will be a loss of tractive force. If you remember, we have discussed this. So P minus P cos theta, there will be a loss of tractive force, a loss of power for the vehicle. Okay, similarly when this horizontal curve, consider this horizontal curve is coming in a vertical curve, or consider there is a gradient is coming in this horizontal curve also. So it is not a straight road, consider the gradient is coming like this, and then there is a horizontal curve is coming. So the straight road supposed to be like this. Now we are experiencing gradient and also there is a horizontal curve. Understood? When a gradient is approaching, that's what I am telling you, when the gradient is approaching a horizontal curve, already we know there will be a loss because of the horizontal curve. When there is a gradient also, your vehicle has to negotiate the gradient too, correct? So IRCS recommend, already there is a power loss because of a horizontal curve, so we no need to provide the same gradient, we can compensate some gradient. How much we can compensate? They have provided some 3 points. If you see the grade first point suggested by IRC is for flatter, means plain topography, gradient, first they have given a grade compensation is not required if the gradient is lesser than the 4%. Okay, because loss of tractive force is also very negligible, and if the gradient is lesser than 4%, no need to do any grade compensation. But if the gradient is more than 4%, we have to do the compensation. We are going to not provide the same gradient, we are going to do some grade compensation. How much is? We have to provide 30 plus R by R, determine based on the horizontal curve, determine how much to be compensated, provide the minimum value. Okay, so determine 30 plus R by R, and also separately you also determine 75 by R, provide the minimum value, that much of gradient can be compensated. Okay, so let's see with an example. Consider there is a gradient is coming on a highway. So consider there is a gradient is coming on a highway, and so the road supposed to be like this. Now the grade, because of the gradient, the road is something like this, and the slope is 1 in 16, means for every 16 meter 1 meter raise, and this road is about to meet a horizontal curve, something like this. So the horizontal curve's radius is 150 meter. So they are asking what is grade compensation. Okay, so you can see this. So this is 1 in 16 actually. Oh sorry. So take this question as 1 in 15. 1 in 15. Okay. So take this as question as 1 in 15. So for 1 by 15, if you see, we'll get 6.67%. That is given. So the gradient coming in a straight road is, already there is a straight road which is having a gradient of 6.67%, and determine the grade compensation. We know 30 plus R by R. So R radius is 150 by 150. We will provide, if you substitute, you will get 1.2%, and 75 by R you will get 0.5%. We know we have to provide the minimum value, so 0.5%. As per the question, if you see, they are asking grade compensation. Since they asked only grade compensation, our answer is 0.5%. Consider if they are asking, and you have to check that 4, whether the given percentage is more than 4, right? Since it is given 6.7, then it is fine. Okay, so the question can be in two ways. If they are asking grade compensation, so obviously from above you know that answer is 0.4 percentage. The same question can be twisted, like if they are asking compensated gradient, how much gradient to be compensated. Okay, we know we are coming with 6.67, and now we know we have to compensate 0.5. So now then we have to provide 6.17 percentage. So remember, the question can be twisted in two ways. The grade compensation, if they are asking, the answer is 0.5. If they are asking for a compensated gradient, how much gradient is compensated, then we have to say the answer is 6.17 percentage. Okay, so if you see, if as per IRC, if there is no gradient, if there is no gradient, then it is fine. If there is a gradient is coming of 6.67 percentage and it is meeting a horizontal curve of radius 150 meter, we no need to provide the same 6.67, we can provide only 6.17 percentage. Okay, so this is called grade compensation. We have compensated the grade for the loss to be incurred by the vehicle is somewhat negotiated. Okay, so thank you. This is for gradient. We will see about summit curve in our next session. Thank you.